Okay. So there's four types of slopes that you can see in any type of an equation. The first one being a positive slope, right? A positive slope is a line that looks kind of like so. Where again, if we go from left to right on the x-axis, the y values increase. Okay? So a positive slope always is in that kind of shape, right? Sloping upwards, right? So a negative slope, this picture, kind of looks like this. So again, as we go from left to right on the x-axis, the y values go down. Okay? Those are the two most common ones that we see. All right? Now, the more uncommon ones are when you see a zero slope or an undefined slope. A zero slope is basically a horizontal line. So I'm gonna just go straight across here at 3. Okay? These lines have zero slope. Why? Because there's no rise. Okay? The run goes on forever, right? It goes left and right forever, and it's parallel to the x-axis, but there's no rise. So this slope is always 0. A horizontal line slope is 0. So remember, when you see rise over run, with that number on top, and it doesn't matter what the bottom is, because it runs forever. You can even put the infinity sign, but any number times whatever is 0, right? If I take 0 times any number, that's why it's a 0 slope. Now, when I see a vertical line, like, I don't know, if I go up -2, a vertical line is a little different. We call that an undefined slope because of the math that is involved in it. Remember, rise over run, right? So this thing rises forever, right? Right? But there's no run. There's no left and right, right? So that's like saying if you had a slope of 6 over 0, because again, there's no run. There's the rise can go right. Now, some number times 0 gives you 6. Is that mathematically possible? Some number times 0 equals 6. Is that possible? No. No number times 0 is 6. Any number times 0 is 0. So we always say that when you see a problem like this, that's undefined also, which is why the slope, we would call it undefined. So a vertical line is undefined. A horizontal is 0. Okay, so those are the four different types of slope that we'll encounter. So if you flip the page over to the back, there's four boxes here. Today, we are only going to concentrate on 2 of those boxes. Finding a slope from a graph and finding a slope from an equation. So the top right and the bottom left. The other 2 boxes we will do tomorrow. So let's fill in this middle box here. What is slope? Slope describes the blank of a line. What do you think can fit there? The blank of a line. Give it a shot. Angle, we're going to use steepness. All right. And again, we can show slope in 2 ways. Either the change in y over the change in x, which is kind of an unpopular way to hear it. This is the one you probably hear the most of. Rise over run. Okay? But those are 2 ways that we can show slope. So, for example, if I give you a graph, okay, like we got over here in the upper right-hand corner, all right, and this is a line I drew earlier, so I'm going to put some points on here. That's not there. That's there. That's there. And my board looks like it's a little off, but we'll deal with it. All right, so here are the steps. Choose 2 points on the line. Now again, a line has lots of points, right? All you need to do is pick 2 of them. All right? Count the rise, then the run. And then you want to write the slope as y over x. All right? So, to do that, here's how we're going to do it. All right? Pick 2 points. You can go from, you can go here to here, you can go here to here, you can skip one. It doesn't matter. Okay? So let's skip one just for the heck of it. If I go from this point here, we'll make this a little bigger, and this point here, right? So how high do I have to go? How many units do I have to go to get even with that other point? 4, right? So the rise is 4, right? Change in y. We're going up 4 units, right? Now we got to look at the run. How far over do I have to get to touch the point? Brent? 4. So the run is 4, or the change in x is 4. So we wrote it as y over x, right? We can always reduce these fractions. What's 4 over 4? 1. So our slope for this line is 1. And that's how we can do that, by looking at a graph. Pretty simple, right? All right, let's go to the lower left-hand corner, finding an equation. Okay. Remember, the equation of a line is always y equals mx plus b, right? So we want to make sure the equation, solve the equation for y, right? So we just want to make sure we get it in this form. Sometimes they give it to us really nice, so they're already in that form. Sometimes we have to do a little bit of our algebra skills to get it into that form. So I'm going to show you 3 examples in here of kind of how easy they can be, and sometimes just how much little bit of work we got to put into it. All right. So the slope is the rate of change. Therefore, it is next to the variable x, right? And we see that here, right? It's the letter in front of the x, right? What do we call that letter in front of the x? What was our math term for the letter in front of the x? Started with a C. Coefficient, and that's number 3. So the slope is the coefficient of x. It's the number in front of the x. So when we have an equation, and they're asking us just to find the slope of it, if it's written in y equals mx plus b form, all we got to do is look at the coefficient, and that's our answer. So that's why some of you might be looking at the homework going, wow, there's a lot of problems here. Well, like these ones take like 3 seconds to do. All right, let me show you one. So you're given that equation, and I say, what is the slope? What are you going to tell me? 1/2, right? Because that's the number in front of the x. That's how easy that is. Doesn't take a lot of thought, does it? It's right there. What about this one? What's the slope of that line? 3, right? Because it's the number in front of the x. All right. Now, what if I give you something crazy? All right, I'm going to use this example here. What if you see something like that? First of all, is it in y equals mx plus b form? No, and that was the very first thing we had to do, right? We had to get in that form. So now we have to use some algebra skills to maneuver it, okay? We got to get it into this form, which means we got to get y equals, which means we got to take all this and put it on the right-hand side, right? Well, by order of operations, what do I have to do first? Huh? Okay, can I add x plus 8? Okay, no, because they're not like terms. So what if I can't do something inside the parentheses and there's no exponents, what's the second thing I have to do, Nick? Distribute. So I'm going to multiply this 2 into x and into 8, right? So 2 times x is 2x, and 2 times 8 is 16. And then we got plus y equals 4. All right, I have no like terms here, right? 2x, 16, and y are all different, right? What's the only thing that's got to be on the left-hand side when it's all said and done? What's got to be by itself? Y, right? So I got to move the 2x, I got to move the 16 over, right? Well, let's move the 16 first because there's a 4 on the other side, right? Aren't those like terms? So how can I move 16 to the other side of the equal sign? Subtract, right? Just like when we were solving equations, I could subtract. So I do it to both sides. So that goes away. I'm left now with just 2x plus y. And over here, 4 minus 16 is negative 12. Yep, we're going to kind of write right over this in just a second. Now, the only thing I got to get rid of is this 2x. Now, unlike solving equations, where we got the x by itself, I don't want to get the x by, I got to get y by itself. So I got to move this whole thing over to here. So if we had like 4, how did I move 4 over? Like here, we move the 12 by doing its inverse, right? So what's the opposite of 2x? How can I make 2x 0? I want to leave y by itself, so I could get this whole thing over to here. Brett? Not divide by 2, because that leaves the x on the other side. I got to do something else. Yeah, we're just going to subtract it, because it's positive, right? So I'm going to subtract 2x to both sides. Because 2x minus 2x gives me 0, right? That's gone. And guess what's all by itself? Isn't that what we need for this? Right? So now, I got a minus 12 and a minus 2x. Are those like terms? No. So we're just going to write it out as, because it can't combine them. Well, guess what? Aren't I in slope-intercept form? What's the slope? Negative 2. So that's sometimes if we have to do a little bit of work. We have to get it in the slope-intercept form. Not too bad? All right, now I did talk a little earlier, if you go to the next page, is about horizontal and vertical lines. Well, there's a little part in here for it. All right. So it says identify the coordinates for 3 points on the line. So look at the 3 points that are on this line here, right? Here's your y-intercept. Here's your x-axis. Y-axis, x-axis. So here's our line right here. So who can tell me one of those 3 points? Brett. Negative 3, negative 1 is over here, right here. Okay, that's not on the line. Remember, what's our coordinates, right? It's written as this. X, Y, right? So who can tell me what one of these points are? All right, 0, negative 3. That's right there, right? So 0, negative 3 is 1. All right. Who can give me another point? 0, negative 3 is the 1. It's the one in the middle. So what about the other ones? Now you got 2 options left, Nick. Right here. Negative 1, negative 3 is right there. Good. So negative 1, negative 3. So what's the last point? All the way to the right. This one right here. What's this one? Justin, what's that point? 5, 3 is up here. No, negative 5 is this way. The y values go down. They're negative. So 5 down 3 is negative 3. So there are 3 points. What do these points all have in common? Look at those 3 I wrote down. What do all 3 of those points have in common, Brooklyn? Not 3s. Right? The negative 3 is same in all of them, right? So they all share the same y coordinate. The y values are all the same, which is why this line goes horizontally. So it says, how could you write an equation for this line that states in a symbolic way that what represents all the points on that line have in common? Well, remember, think of y equals mx plus b, right? So this line has what kind of slope? What do we learn from the front side? The line that goes horizontal has what kind of slope? 0, right? So if I just were to fill this in, 0x, and the y-intercept, well, what's the point that hits the y-axis? Negative 3, right? So here's our equation. Do we really need to write 0x? No. So I can literally take this part out, So our equation is actually y equals negative 3. So an equation of a horizontal line is y equals negative 3. The reason being is because all those points are at negative 3, no matter what the x value is. It doesn't matter what we put in for x, y is always negative 3. Okay? That's why we have a horizontal line. So again, we just answered that question, right? What is the slope of a horizontal line? 0. We found that out from the front. So what if I draw a different one? All right? So here, let me erase this. Okay? I'm going to draw a different line. I'm going to go right here. I'm going to try to draw this as straight as possible, but we all know that's not going to happen. Okay, so there's our line. All right? So we drew a different line in the same plane. What do you think the equation of this line is? Think about what we did for this line. This line was this, right? So if y equals negative 3 was this line, what do you think the equation for this line would be? Elizabeth? Y equals 2. And why would you say that? All the y coordinates for this are at 2, right? Doesn't matter what x is, y is always 2. So again, what's the slope of that line? What's the slope of this line? 0. It's still a horizontal line, right? So the slope is still 0. It's just on a different point. All horizontal lines have a slope of 0, no matter what you write. Okay? All right. Now, if you look on that same page, it says identify the coordinates of the 3 points on this line. Now we're going to go to the vertical line. Everyone got this down? Good? All right. So now we got the vertical line. Looks like this, right? So give me one of those 3 points. Somebody new. I'm tired of watching the same people raise their hand all the time. Must start picking on some people. Rachel, give me one of the points. One of these 3 points. Four and 1. So again, we start the origin. 1, 2, 3, 4, and 1. That's right here, right? 4, 1. So, okay, there it is. All right. So now, give me another point. Alex? Huh? 4 and 2. The point right above it, right? 4, 2. Good. And then that leaves 1 left, right? Anna? 4. 1, 2, 3. So it's 4 what? If I went down, 1, 2, 3. So it's 4 negative. 5 is down here. So 4 negative 4. Okay, so those are the 3 points, right? So again, what do those points all have in common? Nick? They have a what? They have the 4 is the same now, right? So the horizontal line, all the y's were the same, right? On the vertical line, all the x coordinates parts are the same. So no matter what y is, x is always 4. So remember how we wrote the equation for the horizontal line, y equals? What do you think the equation for that line could be? How could you write an equation for this line that states in a symbolic way of all the points having in common? Just like we did for the other one. But it can't be the same line, right? Because they're not going the same direction. So what do you think we could write for this one? Brett? There's no y. X equals 4. Because all the x points are at 4. Just like we did the horizontal ones, all the y points equal whatever where is that? Same thing with the vertical lines. This is an equation for a vertical line. And all this tells you is all the x points are at 4. It doesn't matter what y is. Now, why isn't there any y-intercept here? Because if you notice, does it touch this axis at all? Does it touch the y-axis at all? No, it doesn't have a y-intercept. It's not parallel to it. It also has an undefined slope, which is why we don't have a number in front of the x, because the slope is undefined. That's just the equation for it. So again, what's the slope of a vertical line? Undefined. Drill that into your head, guys. Undefined, undefined, undefined. So, hold on, we're not done yet. So if I draw you a different vertical line, just like we did. If I draw this one, okay? What would be the equation of that line? If the line that we had was x equals 4, what's that one? Ethan. What x points are all the same? The one I just drew in green here. Someone help him, Xander? It's all 1, right? So our equation for this line would be x equals 1. All right, so here's what we're going to do.